Today we're moving on to Unit 3. Little bit of bad news. Unit 3 is long, and Unit 3 has some tough stuff in it, okay? Um, Today what we're doing, I don't consider easy. Some of you guys, when we're done today, might consider it easy, but I don't consider this easy, all right? We're doing slope today. Uh, so if you remember slope from last year, you might be like, oh my gosh, hopefully we're going to do some things that make slope a little easier. Today, I taught Coach Shavers new ways to do slope to make it easier. And so even Coach Shavers today was like, oh my gosh, why did we ever do it the other way? Okay, so we're going to hopefully make slope a little bit easier. But even though we're making it easier, slope is just not an easy concept. Okay, so if you can get this stuff today, then you're already looking at making a higher grade on a test. This isn't the easy stuff we look for. All right, so but if you can make it easy today, that's awesome. All right, I do want you to see this green. All this green right here is all this unit right here. So we're still going to have some domain and range. We're still going to have some attributes. It's going to have all that. Plus, these two posters, which are in yellow right here, actually are a big part of this unit. And so we're going to be using this stuff right here as well. Okay, so it's a pretty big unit. There's some tough stuff in this. All right, but today we're talking just about slope. All right, and so right here now, those of you that are online, if it looks like notes, you don't have to write it down because you don't have a worksheet. You only have to write down the towards the middle of class when we get to the problems. All right, all of y'all in class got to write this down because y'all got a worksheet. All right. So right here, the steepness of a line is called slope. Okay. So slope describes how steep a line is. Okay. And right here, it says circle the line with the biggest slope. The steeper the line, the bigger the slope. So like this line right here is not going to have a very big number. It's not very steep. This line, it's going to be a little bit bigger. This line is the steepest slope. That's going to have the biggest number. Now, here's what I love about math. In math, we have numbers that describe how steep something is, okay? But that isn't always how the world works. If we were going to be on this for 2 days, I would share with you my skiing story, the whole story. But because I don't have 2 days, I'm just going to give you a little bitty part of my story, okay? When I was in high school, someone paid for me to go skiing. Okay, they're like, we're going skiing and we'll pay for you to go skiing. Now, I hate the cold with a passion, absolutely hate the cold. And I don't like heights. Okay, so skiing for me was like, why would I ever do it? And I wouldn't have, except someone was nice enough to say, we'll pay for everything if you'll go skiing. So I was like, okay, I'm going to go. Well, we started off on at ski school. We started off on the bunny slope. Now, I just want you to hear the name of this, the bunny slope. What do you think of the bunny slope? It's no. The bunny slope is for the little kids. This is the bunny, your cute, cuddly little bunny. This is the least scary part of the mountain. Okay. So guess where I stayed the entire day? The bunny slope. Okay. And I was terrible at skiing. Okay. There's just something about me and heights and the idea of jumping. Because when you ski, you got to put your feet together and you jump like this right here. And then you jump. I'm on the side of a mountain. My feet aren't leaving the mountain. Okay. And so I did something that was called snow plowing. And I put my skis together and I just slowly went down the mountain. So I'm skiing with all these little kids and I don't know how to ski. And so they're all skiing past me. Get out of the way, because I was in the way because I couldn't ski. And I'm like, if I catch you, you're dead. But they were too quick for me, so I never caught them. And so I'm just slowly going down. However, I could live on the bunny slope, and I stayed on the bunny slope all day. Well, that night, one of my friends was like, okay, tomorrow we're going to go to green. Oh, green. What's green? And they're like, oh, green is just like the bunny slope. Okay, well, I learned the next day, don't ever trust colors. See, they didn't give me a number. They just said, oh, it's just like the green was not like the bunny slope at all. Okay. I got up there and that sucker was so much steeper. I ended up just getting on my butt and scooting my way all the way down the mountain because that was crazy. I was not doing great. And of course, there's even crazier colors where you're like skiing like on this right here, just going down, right? So if any of y'all have ever been going skiing, they got some crazy, and like what you were talking about where you got these, what I think they call moguls, where you're doing all these crazy jumps and stuff. Yeah, no, that ain't me at all. And so, anyways, I love math because it puts a number to it, not a color. Don't trust colors ever. So if you ever go skiing, don't trust any colors, man. Go find out what that slope is before you go on. All right. So we're gonna do a lot of skipping today, and I apologize about that, but we're gonna be moving around. There's a lot of people that do slope differently than me. Okay. So if you've ever hated slope before, hopefully the way I do it makes it just a little bit better. So we're going to look at this right here, but we're not going to look at the rest of it because I don't do slope like the rest of this way right here. This first thing right here says mark some points on the line. Now, why are we talking about marking points on line? Because we want to make sure you understand we're looking for what's called perfect points. Or if you did this last year, your teachers might have called them pretty points. Okay, but I call them perfect points. What is a perfect point? So a perfect point is anywhere the x coordinates and the y coordinates meet, right? These are all perfect points. But I'm looking for perfect points that the blue line is on. So these aren't my perfect points right here that I'm looking for. I'm looking for perfect points right here. Usually, not always, but usually the y-intercept is a perfect point. So do me a favor, on your paper right here, put a dot right here. That is a perfect point right there. Does everybody see that? Now, if you follow this line, is this a perfect point right here? No. This is in between perfect points. So we can't put a dot right here. But if I get right here, this is a perfect point because it's where the two lines intersect. Any place where two lines intersect is a perfect point. We can also keep going right there. We can even go backwards. This is a perfect point. So I want you to mark all these points. And I know that seems dumb, but we want to make sure we understand what a perfect point is. Okay. So make sure you're writing these down. Make sure you're writing them down. Okay. All these dots. Okay. These are perfect points. And they're just anywhere that my line touches. So anywhere, yep. And there, and there. So anywhere my line touches where the x coordinates and y coordinates meet. Okay. Now, the reason that we need to know these perfect points is because you can only do slope from perfect points, right? You can't do slope from a point that's in between perfect points. Okay. Does that kind of make sense to everybody? Like I said, I know that kind of seems dumb, but it's just something you got to make sure everybody understands that slope is only done from perfect points. All right. We skipping some more. All right, down here, the only thing that we want to look at this is we want to make sure you know that, first off, this is the exact same line that we just drew our perfect points on. Okay, this is the exact same. Okay, and so they're going to, sorry, I got someone entering. We got to make sure you got on. Sometimes they don't. Yeah, didn't do it. Okay. So from right here, we're going to do rise over run. Do y'all remember rise over run? All right. So the only place I really have rise over run written is right here. I don't always refer to it as rise over run. Sometimes I say changing Y over changing X, but it's always going that up and over. So hopefully y'all remember a little bit about it, right? And so this right here is doing that rise over run, and it's going up one. So the one is your rise, and then over two. So your slope would be 1/2. Is the slope the same all the way throughout? Yeah, it is. So I keep going up one over two, up one over two, up one over two. So in linears, which this whole unit is on linears, they're all line, the slope is the same in the entire line. Just to prove it, on this line right here, they got rid of this middle dot right here. So see that middle dot? They just got rid of it. Is that going to change my slope? Well, now I'm going up 2 and over 4. Well, it kind of looks like it changed it, but it's a fraction, and fractions reduce, don't they? Now, will you ever have to reduce a fraction? No, our calculator will reduce it for it. So if I put this in the calculator, it would reduce to 1/2 because these are still the same lines, even though I went from different points. Does that kind of make sense? If I go from even different points, it's still the same line. We get 3/6, that reduces to 1/2. We get 4/8, that reduces to 1/2. Do y'all kind of see what we're talking about there? So it doesn't matter what points you pick to do this from, it will always reduce to the same fraction, okay? Depending on what the slope is. So in this case, in all these lines, the slope was 1/2. So it'll always reduce to 1/2, okay? And then, of course, you'll have different slopes that will reduce to different things. All right. So, all right. So the first thing that I want you to do is to draw this negative right here, okay? Now, if this was a test, immediately you would go eliminate all the positives. Does that make sense? Okay. All right. Now we're going to draw our fraction, and we're doing rise over run. Okay. So to do rise over run, we got to find two perfect points. Usually the y-intercept. So usually the y-intercept is going to be a perfect point. So draw that point on there. Okay. Now I know y'all's paper, this is a lot smaller, isn't it? It's kind of hard to see. But as I follow this line, that looks like it's above the point. So I don't think that's a perfect point. That's definitely not a point. That looks like that's below the point. I would say I don't have a perfect point until right here. All right, so now we got to do our rise over run. But to do our rise over run, we got to practice counting. And I know this is going to seem weird, but you wouldn't believe how many kids struggle with the next thing that we're about to work on. I'm going to take some steps, and I need y'all to count how many steps I take, okay? And like I said, I know this seems weird, like how hard is it to count? But kids screw up on this all the time. This is like the number one reason I see kids screw up on slope. All right, y'all ready? So I'm going to take steps. Y'all ready to start counting? Okay, very good. Now, I know this seems weird, but did anybody start counting before I took a step? No, nobody did, right? Because you don't count this right here as one. You don't count one until I move. This is the number one mistake we see right here. Kids count this point right here as one. Does that make sense? So make sure you don't count wherever you start. And I know this sounds stupid. You're like, Settles, that is the dumbest thing I've ever heard. Kids do this all the time. Okay. They will count this point right here as one and then go 2, 3, 4. That's not 4. Okay. Now we're going to make an L shape. So it can be an upside down L, a regular L, a backwards L. Okay. But we're going to go from one point to the other point, and we start as soon as we start moving. So we would go down 1, 2, 3. Now notice we have to go up or down first. Matter of fact, it really doesn't even matter which point you start at. You could have started at this point and gone up 3. Whether I go down 3 or up 3, 3 is my rise. So you always go up or down first. Okay, always. Just depending on the point that you chose to start at. Then we count over. So how many did we go over? 1, 2, 3, 4. So our slope is going to be -3/4. And this is rise over run. So some of y'all might have already been good at this. And some of y'all, this might have been really difficult for you last year. Okay. So if this is difficult, and I'm not saying that in a bad way. I mean, there's just people that really struggle with slope. The one thing I expect you to be able to do is that negative or positive. That's the one thing I expect everybody to be able to do. All right, take a look at the second one. So if my slope guy is right here, and sometimes you got to draw him over on the left-hand side, always on the left, is this a positive or a negative slope? Here's my slope guy. Is he going uphill or downhill? Uphill. So uphill would be puff, puff, positive. I want you to go ahead and put a positive symbol right there. We never put positive symbols, but I do it on slope so that I can sit there and say that I've definitely taken care of my positive and my negative. So I definitely want that. At this point, I would go eliminate all the negative answers. All right, so now we got to find our perfect points and draw our fraction bar. All right, we got a perfect point here. And I don't care if you go up or down. I'm going to go up. I would say my next perfect point is right there. All right. It doesn't matter which dot you start at. Okay. I always start at the left one. That's just me. So we have to go either up or down first. Remember, slope is backwards. We do the y's first. So I'm going to go up 1, 2, 3, 4, and then over 1. Now, if you put this in the calculator, this reduces to just 4. So any number over 1 just reduces to whatever's on top. Okay, but the calculator will do that for you. All right, we're going to get a lot more work on this kind of slope right here. And so for today, I'm going to go ahead and move into another part of slope. All right. So we're going to stop right there with those, and we are going to move all the way down to this right here. All right, now, because we have our calculator, we don't have to worry about a lot of the stuff that was above this. So your calculator helps you guys so much that the stuff that's right above this, dealing with all the fractions, we don't need to worry about because your calculator will take care of it all. Okay, that's why we love our calculator. It makes our lives so much easier. All right, so you guys are going to have to help me here. Where you guys taught, anytime that there were 2 points like this, the slope formula that says y2 minus y1 over x2 minus x1, has anybody taught that? No? Okay, well, that's good because I don't use it. But they do give this formula to you on the STAR test, okay? So they do give it to you on the STAR test, but I don't use that formula right there, okay? So I use this over here. So right over here is where I do slope. So whether it's from points or whether it's from a table, this is how I do slope. And this is the formula we use right here. And all it says is we're going to subtract our y's on top and subtract the x's on the bottom. Here's the key thing. We're always subtracting every single time. You will never put a plus sign whenever we are dealing with slope. Okay, always a mind. So because slope is backwards and we always start with the y's, we will always circle the y's first. So I want you guys to circle these 2 y's right here. Circle those 2 y's, okay? So we're at the very bottom, and I want you to circle your 2 y's right here, okay? So circle, very good. So we're circling our 2 y's. If you take care of the y's, then this may not be so bad, okay? All right, so you're going to draw a fraction bar. And the rule is we subtract the y's. It doesn't matter which one you use first. But me personally, I always put the first one I see first. So I put -1 minus 2. Okay? The first one you see is the first one you write down. All right? We always put a minus sign right here. Now, here's where you can mess up a little bit. If we put -1 first for the y's, I have to use its buddy on the bottom for the x's. What number is with -1? What's -1's buddy right here? The 4. So when I subtract the x's on the bottom, I got to start with -1's buddy. Now, had I put 2 first, I would have started with 6 on the bottom first. Does that make sense? Whatever number you put first, you got to use its buddy first on the bottom. So we're going to put 4 first on the bottom. We always subtract, and then we subtract the other x. So we're subtracting the x's on bottom. Now, because this is all numbers, our calculator will do this one. So we're going to use calculator on this. So I want y'all to pull out your calculator. Those of you that are online, you should be getting this calculator, I thought sometime this week. Okay. So you need to start, even if it's not this week, you need to start learning this calculator because you will be using this calculator, if not this week, then definitely next week. So there's only 2 buttons we hit here. Okay. On calculate, scratchpad is okay, but I never hit it. So I use this for calculator and this for graph. So I'm going to hit this one right here. All right. So since we're going to put in a big fraction, that means start with the fraction. So you're going to start by hitting Control Divide and get that fraction bar in there first. Okay. I don't know if y'all can still see this right here, but This is -1, -2. Remember, we only use the minus sign. Don't ever use that negative sign right there. Always use the minus sign. So we're going to go -1, -2. So type that in real quick. -1, -2. Always use the minus sign. Then on the bottom, we're going to go 4 minus 6. Now, if you type this in properly, all you got to do is hit enter, and it's going to work everything out on top, everything out on bottom, and it will reduce it. So it will take care of absolutely everything. So you hit enter, what'd you get? Did y'all get 3/2? So control divide. And we're typing that in. 3/2, very good. And so it's all calculated. Okay. We hit enter, and boom, it does everything for us. All right, so let's take a look at this one right here. So the first thing, so our answer right there was 3/2. Okay, calculator did everything for us. Okay, so on this one right here, we take care of the y's first. So circle the y's. Remember, this is only on slope that we take care of the y's first. Okay, so we always take care of the y's first. We are subtracting them. So we're going to go -2. I just start with the first y that I see, and then -3. So we're subtracting our y's. All right. What is -2's buddy? 3. So 3 goes on the bottom minus the other x, and we're subtracting our x's on the bottom. So it's 3 minus 4. Always put a minus sign. Very good. So throw this into your calculator. So we're going to go put this in the calculator, and you've already got it, but I want everybody else to be able to practice it. So we're going to go control divide. Control divide gives us our fraction bar. And then we're typing that in using minus signs only. So -2, -3. And then on the bottom, we got 3 minus 4. And what do we get? Just like you said, 5. Okay. Now, a lot of kids have told me today, Settles, this is easy. Well, you're right. If you get everything done perfect, then it's not that bad. So why do I not consider this to be easy? Because there's so many different spots that you can make a mistake. Okay. If you don't circle the y's, if you don't put the y's on top, you've got this wrong. If when you write this in, if you don't put its buddy below it, then you've got this wrong. If you don't put all the minus signs correct, then you got this wrong. So that's why I don't consider this easy. Because there's so many different places you can make a mistake. All right, let's take a look at this one. This one has a little tricky thing to it. So we're going to circle the y's. So circle the y's right here. Okay, so circle your y's. We always, always, always start with the y's. Okay, if you take care of the y's, you've got a really good shot at getting this right. All right, so my y's on top, I see 4, and then we always put a minus, 12. And you never, ever, ever put a plus sign. Not on slope. All right, so then who is 4's buddy? The 0, yeah, so we'll put 0. Now here's where it gets a little weird. I have to put a minus. What is the other x? It's not just 3, it's what? -3. I have to put another minus. That means in the calculator, you're going to put 0 minus -3. And I know that seems weird, but your calculator will do just fine with it. Very good. And so we're going to go plug this into the calculator. And I want you to see that your calculator handles this minus with no problem. So type this in the calculator. All right, so we got 4 minus 12 on top. And then on the bottom, we got 0 minus 3. And like I said, I know that's weird, but you don't ever use this negative symbol. And that minus minus won't screw us up at all. We get negative 8 over 3. Negative 8 over 3. All right, we're going to skip to this question. So we're going to skip this one right here. We're going to skip to this one. All right, so circle the y's. And we have 7 minus 7 on top. Now, I'm not going to lie. I should have been saying this all day today, but when you see the y's are the same, that's a little clue that this is going to be a little special right here. Okay, so so my y's are the same. So 7 minus 7. Then we've got 3 on the bottom. That's his buddy, minus a negative 11. And so we're going to go type this in. Now, y'all don't realize how awesome the calculator is. You kind of probably take it for granted. Very good. But when we were in high school, we actually had to work these out. Even if we had a calculator, it wouldn't work out the entire calculator or the entire problem. And so, yeah, we had to do the top, then we had to do the bottom. And then if we got a 0, it meant something different if it was on top and if it was on bottom. So y'all's calculator does it all. So we go 7 minus 7 here. And then on the bottom, we got 3 minus negative or minus 11. And this calculator knows exactly what to do if there's a 0 on top, and it knows what to do if it's a 0 on the bottom. So if there's a 0 on top, it knows the answer is 0. What kind of a line is this? If this is slope dude, what kind of a line is 0? It's the 0 fun. It's flat, right? So that's what kind of a line this is. All right, so take a look real quick at this last one. So this one was 0. Yes, yes. And it tells you that it says undeaf, but undeaf here is going to mean undefined right there. So, and like I said, we never had a calculator. I think this might be the first calculator I've ever seen. I've seen calculators say error. I've never seen a calculator. Yeah. And so I've never seen a calculator that said undefined. All right. So right here, we're going to take care of the y's. So we're going to go 4 minus 10. And then 4's buddy is negative 5. Now notice that now the x's are the same. So we'll go type this into the calculator. And this is, if you heard us talking, I know that y'all didn't see it. I'm going to clear this out real quick. I'm not going to clear everything, but I'm just going to clear this out. All right. So if I control divide and we do 4 minus 10, and then on the bottom we go minus 5, minus, yep, very good. This calculator will tell you undef, which is undefined. So it's that vertical line right there. And you don't have to know all the rules that go behind it, which is why on this worksheet today, we got to skip a large part of this because the calculator took care of everything. So if we didn't have this calculator, I would have had to have taught you a totally different section where we talked about when it's 0 and when it's undefined, but your calculator will do everything for you. So I hope you appreciate this calculator a little bit. Okay, it's awesome. All right, with that being said, we are done for today.